Mathematics 2, May 2016 exam. Question 10. Determine the following integrals. We've got the integral of x times log x. We've got two pieces to this, so we need to do it by parts. So what we're going to do is we're going to let u equal log x and dv equal x. So du is equal to 1 over x and v is equal to x squared over 2. So now we're going to put those back into the expression. So I, the integral, is equal to uv minus v du. So u is log x and v is x squared over 2, so that's uv minus v is x squared over 2 and du is 1 over x. So that x will cancel with that x, giving us the integral of x over 2. We can integrate that to give us x squared over 2, and there's another 2 there, which is where the 4 comes from, and then we've got a constant of integration. We can tidy this up a little bit. We've got x squared over 2 in both terms, so I can take x squared over 2 outside a bracket. So I'm going to get x squared over 2 outside a bracket containing log x minus a half plus a constant of integration. Part 2. We've got x cubed e to the 2x. So we're going to use integration by parts again. We'll let x cubed equal u and e to the 2x equal dv. So du is equal to 3x squared and v is equal to e to the 2x over 2. So if we substitute those into the expression, we've got the integral is equal to uv, u is x cubed, v is e to the 2x over 2 minus v du. V is e to the 2x over 2, e to the 2x over 2, and du is 3x squared. So I've taken the 2 and the 3 outside, so we've now just got x squared e to the 2x. Now, we started with x cubed and now we've got x squared, so we can see where this is going, and we're going to have to do this 2 more times. So what I'm going to do now is I'm going to take this bracket here. I'm ignoring the sign and the 3 over 2 and just taking x. I'm going to call this I1, integral 1. So now I'm going to let u1 equal x squared and dv1 equal e to the 2x. So I'm just going to repeat this process but with x squared instead of x cubed. So now I1 becomes u1 v1 minus v1 du1 dx. I've got e to the 2x over 2 times 2x. The 2's will cancel, giving me x e to the 2x. I'm now going to take this part and call that I2. So I2 equals x e to the 2x. I'm ignoring the sign for now. So u2 is equal to x and dv2 is equal to e to the 2x. So du2 is equal to 1 and v is equal to e to the 2x over 2. So substituting that into I2, I get uv minus v du. Now I can integrate that, so I'm going to get e to the 2x over 4. And now I'm going to back substitute all of these into this expression here. So be careful of the signs and be careful of the coefficients. So I've got x cubed e to the 2x over 2, x cubed e to the 2x over 2, minus 3 over 2, brackets. Then it's I1, which is x squared e to the 2x over 2, x squared e to the 2x over 2, minus brackets. This is I2, x e to the 2x over 2, x e to the 2x over 2, minus e to the 2x over 4, plus the constant of integration. I'm going to take e to the 2x over 2 outside of a bracket, so I'm going to get e to the 2x over 2 outside x cubed, which is from there. In the second term I'm going to get 3x squared over 2. For the third term I'm going to get, there's a minus and a minus, I'm going to get a plus 3x over 2. And then for the fourth term I'm going to get 3 over 4, because the e to the 2x and that 2 will go outside, plus a constant. Part 3. integrate e to the 2x cos x. We'll let u equal e to the 2x and we'll let dv equal cos x. So du is equal to 2e to the 2x, that's the differential of that, and v is sine x. Just check, differentiate sine, you get cos. So we've got the signs right. So I, the integral now, equals uv, so it's u e to the 2x v, which is sine x, so that's uv minus v du dx, which is sine x times 2e to the 2x. This time I'm going to take the whole of that expression and call that I1. So I1 equals 2e to the 2x sine x dx, u is equal to 2e to the 2x, and dv1 equals sine x. So differentiate 2e to the 2x, I get 4e to the 2x, and integrate sine x, I'm going to get minus cos x. If you differentiate cos, you get minus sine, so if you integrate sine, you get minus cos. So putting those back into I1, I'm going to get u1 v1 minus v1, which is the cos x, du1. Notice the cos has got a minus, so that minus and a minus gives me a plus. Now remember, e to the 2x cos x is the original integral. I can substitute I into this part of the expression, so I'm going to get I1 is equal to minus 2e to the 2x cos x plus 4i. Now if I substitute this back into here, I'm going to get I is equal to e to the 2x sine x minus a bracket containing this, which is minus 2e to the 2x cos x plus 4i. So if I expand this bracket, this becomes minus 4i, but if I take that onto the left hand side, I'm going to get 5i on that side, and then this will become a positive quantity. So if I take e to the 2x outside, I've got e to the 2x sine x plus 2 cos x, and I've got 5i on the left hand side. So if I divide both sides by 5, I is equal to e to the 2x sine x plus 2 cos x over 5 plus a constant of integration. Part B. When you see the word evaluate, it means find a value for. This is a definite integral from minus 1 to plus 1. We raise the power by 1, so x squared will become x cubed over 3, and the 3 will cancel with that, so that will become x cubed. This will become x squared over 2, and the 2's will cancel, and this will become 5x. So the integral will be x cubed minus x squared plus 5x. Now we put the upper value in, so we're going to get 1 minus 1 plus 5, and then we put the lower value in, so it's minus the lower value, which is going to be minus 1 cubed is minus 1, minus 1 squared is 1, but we have a minus there, so we get another minus 1, and then minus 1 into 5x will give us minus 5. So this is going to be 1 minus 1 is 0, so that will be 5, minus 1 is minus 2, minus 5 makes that minus 7, and then the plus outside means that it's going to be plus 7, so the answer is 12. B2. The integral of cos theta d theta from 0 to pi. Before we do the integration, let's just have a look at what the cos looks like from 0 to pi. Cos goes like this. That's 2 pi. And this is pi. So the cos from 0 to pi is going to have this area here and this area here. The two areas are the same. This is a positive quantity and this is a negative quantity. So that integral is going to give us 0. So what we do is we take the integral from 0 to pi over 2 and we double it. So the integral of cos theta from 0 to pi, we're going to do 2 times that from 0 to pi over 2. If you differentiate sine, you get cos, so if you integrate cos, you get sine. The sine of pi is 1 and the sine of 0 is 0, so we're going to get 2 outside 1 minus 0, and that's going to give us the answer of 2. B3. Integrate e to the 2t from -1 to +1. The integral is going to give us e to the 2t over 2, and then we put the value of 1 in and the value of -1, so e to the 2 is 7.3891 and e to the -2 is 0.1353. Subtract that from that and divide by 2 and we get an answer of 3.63.